All right, so now we're talking about double angles. So double angles, don't be scared, bro. They come straight from they're coming straight from compound angles, right? So look at the case where you have for sine. Look at the case where you have sine sine alpha plus alpha, which is exactly 2 alpha, meaning that you will have sine this alpha cos this alpha, right, plus cos this alpha sine this alpha, right? And then you can just maybe group it or structure it nicely. It's a multiplication, meaning you can also write it as sine alpha cos alpha, which you end up with 2 sine alpha cos alpha, right? So what are we saying? We are then saying, therefore, sine 2 alpha is going to be equals to 2 sine alpha cos alpha, right? Cool. How about cos 2 alpha? It's gonna be this one. I'm sure you can do it by yourself after seeing the sine one, right? And then we know this is cos alpha, this alpha, cos that alpha. Then the sine is plus, so we have minus sine the first alpha sine the second alpha. So which is saying that you have cos squared alpha minus sine squared alpha, right? Which we can then conclude to say, therefore, cos 2 alpha equals to this. And from cos 2 alpha, right, you can remember now, remember we have this identity, ne? Cos squared theta plus sine squared theta equals to 1, right? So we then say, using this identity, we can then come and say, therefore, cos 2 alpha can also be equals to, if we write cos as a subject of the formula, we're going to have cos being what? Cos is going to be 1 minus sine squared theta, but in this case sine squared alpha. Then I have minus sine squared alpha, which is 1 minus 2 sine squared alpha, right? I can change it and talk about, now I'm changing, writing sine as a subject of the formula here. Therefore I have cos squared alpha, then I have a minus into, if I write the sine, I'm going to have 1 minus cos squared alpha, which gives me cos squared alpha plus cos squared alpha minus 1, which gives me 2 cos squared alpha minus 1, right? So for sine 2 alpha, it was just this, that was it. For cos 2 alpha, we have this being number 1, we have this being number 2, and we have this being number 3. And bro, you can derive it, or you can change it as far as you want to go, right? So cool. Now they say without the use of a calculator, find sine that, right? Find sine that. Now the question is, how do we do it? Nah. How do we do it? Cool. So let's cook. from here, what do you see, bro? I can write this as sine alpha equals to 8/10. Right, after writing that, I go and I draw my triangle, and then I say this is alpha, and therefore sine alpha is 8/10. Right, and then to find this angle, of course, it's gonna be square root of, you can do Pythagoras, it's gonna be, okay, let me do it, 8 squared plus x squared equals to 110 squared. Right, so x squared 100 minus 64. Right, let me see, 8 squared 64, right? Yeah, and then x squared is equals to 100 minus 64, 36, and therefore x is equals to 6. Right, so this is gonna be 6. So now I have all the sides. I know for sure that sine 2 alpha is equals to 2 sine alpha cos alpha. So I have 2, I can say 8/10, and then cos is gonna be cos alpha 6/10, which means that I have 2 times 8 times 6. Right, I have 96. 2 times 8 times 6 over 100. You see? So yeah, I can test it out. So of course I'm getting 0.96. I can test it out and use a calculator. If I use a calculator, I will say alpha equals to sine 0.8. Right, so I'm getting 53.13 degrees. So now sine 2 alpha is gonna be 2 times 53.13, right? Yeah, which is 0.96. Bro, we're killing this thing. We are killing this thing. So yeah, don't stress, guys. Trigonometric grade 12 is so easy. Cool. So now we're going to prove these identities. Prove that the left and the right are the same. We're gonna work the side. So let's say left hand side is gonna be, you see you have 2 there, you have, so let's work. It's sine theta plus 2 sine theta cos theta. Right, you have 1 plus cos theta plus. Right, now it's a question of what do you want to change this to. Right, because I have a cos here, I will change it into the one with a cos. So it's gonna be 2 cos theta squared minus 1. Right, let's see. So here I have sine, I forgot the n here, sine theta plus 2 sine theta cos theta, and then I have cos theta plus 2 cos theta. Right, cool. So if I then do the math, I can take out sine on the numerator, sine theta. So that means I'm gonna have 1 plus 2 cos theta. Then denominator I have cos theta. I have 1 plus 2 cos theta. They cancel, and I have sine theta over sine theta over cos theta, which is tan theta, right? Saying that therefore the left and the right are equal. Cool. Then here we have damn, it's my first time hearing a cat cough. I don't know if you guys can see it. Damn, my first time hearing a cat cough. I don't know if it's coughing or what's happening. Damn, I don't even know what to do if I want to help it. But let's go to maths. Let's go to maths. So, damn. So cool. We are proving that the left and the right are the same. And here I put a note that can x be 45 be part of the solution. Okay. I see what I was doing. So I'm gonna try to remove this. I'm gonna try to remove that. Let me see. There's enough space, and I'm gonna put it. No. I'm gonna put it. I wanna put it up here, right? So after solving this, we need to answer that question. So what do we have? So I think I want to work this side. I want to work out this side. Because of this, I can say, okay, left hand side is gonna be tan is sine 2x cos 2x, right, plus 1 over cos 2x. I'm already seeing 2x, so I can just say it's the same denominators, right? So I can then say sine 2x plus 1 over cos 2x. Now it's a matter of what do I change what into what. I can use this as a clunyana or something, right? So here, what should I change it into, right? Okay, I have an idea. So I'm seeing the denominators here, it's cos minus sine, right? So I know for sure that maybe for this one I can say this is cos squared x minus sine squared x, and I'm hoping that somehow I'm gonna end up with this. And then this side, I know this is 2 sine x cos x. Now it's a question. Okay. Ooh, I am seeing it. I am seeing the vision. So now we change 1 into cos squared x plus sine squared x, right? I see the vision. So now let me structure it this way. Say I have cos squared x plus 2 sine x cos x, and then plus sine squared x, right? And then I have this cos squared x minus sine squared x. Right, now we come into the interesting things for the numerators. Whenever we factorize, bro, I like saying that if I have I have 1 plus x, if I'm squaring these, one of the easiest way to do it without having to do an expansion, you say y squared, which is y squared, you multiply the 2 yx, multiply them by 2, then you have plus 2 x yx, you have 2 yx, and then we square the last one, x squared. So with that, I want you to look at this: x squared, 2xy, 2xy, x, y squared, right? So you see, with that, bro, you already have all the clue you need, So let's write it. So now with what you have done, you know that here you have cos x plus sine x, right, squared, ne? But because of what is coming, I don't have space, ne? So on this line, if I had space, I would write it this way, and then on the next line I would write it like make it 2 brackets, right? But now it's cos squared, so I want to make it like this. Say cos x plus sine x, right? Yeah, so now you see I have it like that. I can now do this, and the reason is, let's look at the denominators. What we have for the denominator, remember, difference of 2 squares. So with difference of 2 squares, that means this is what, this is cos, and this is cos x minus sine x, and then here it's gonna be cos x plus sine x. What is this saying? This is saying that this is difference of 2 squares. There's nothing it says. Difference of 2 squares, that's it, ne? And now what's gonna happen is that something is gonna cancel something. This divides this, and now, bro, we are left with this. So now that means our solution is gonna be these, right? This now becomes our solution because that it's being divided. The division has already happened, and sure. So then this is our solution, right? And when we go back, it's exactly what we were asked to prove: sine x plus cos x over cos x minus, right? So that's nga. So I want to ask you now, do you think if x is 45 degrees, do you think it can be part of the solution, right? And I just want to show you, if cos here, so that means we have 2 times 45 degrees, which is 0, and the cos is a denominator. Also here cos is a denominator, and we have a 2x, which means 2 times 45, which means 90 degrees. That means 90 sine cos 90 is 0, so we're going to have a denominator of 0. So that is just saying that sine can't be part of the solution. Not sine, 45 degrees, right? 45 degrees. But when you look at it on this side, you might say, yeah, perhaps it will be, because then cos x, oh no, it cannot be, because we have cos 45 minus sine 45. It cannot be. Still, you still have a denominator of 0, so there is no way x being 45 is gonna be a denominator. It's gonna be an answer. Oh no. We do these last proofs and we are done. Cool. So for this one, 1 minus sine 2a minus 1 divided by, I'm gonna change this into sine 2a sine, oh no, sine 2a over cos 2a, right? Which, you know, that is 1 over sine 2a, right, minus, then it changes, right? You're gonna have 1 multiply, which don't make a difference, but we have cos 2a over sine 2a, right? And therefore we have 1 minus cos 2a over sine 2a. Right, cool stuff. And then what then do I do? Because now remember, I want to have sine over cos, right? So the denominator, I know for sure that I'm gonna have 2 sine a cos a. So now I need something that's gonna make the a's divide. So I can say 1 minus into 1 minus 2 sine a. Oh, there's a squared here. And then that is 1 minus 1 plus 2 sine. I can write it this way, or I can write it sine a, right? And it is for a reason. I want to write it this way for a very particular reason. Sine a cos a, right? And I have 0 here. Let me just remove them. That is 0. And then after getting that 0, this is gonna divide this, and then I am left with this, which gives me tan a. And now I can say the left and the right are equal. Very beautiful. And hence they say solve for this, right? So when we have this, look, it's exactly the same thing. Eh? We prove that this whole thing is equal to tan a, yeah. And now they say hence proof for this, né? So we can now say that from here we go to tan a equals to 0.75, né? And yeah. So here there's no rule that says without a calculator, so we're just gonna use a calculator. We're just gonna use a calculator. You will say a equals to tan 0.75. There's a minus one, I forgot. 0.75, 36.87, right? 36.87, right? And in fact I can just say, instead of writing a here, I'll just say reference angle, right? And then my reference angle is 36.87. Now I can ask you a question of where is my tangent positive. It's the first quadrant and the last quadrant. That means for the first quadrant, I'm gonna say therefore theta is gonna be 36.87 plus k, or 360k, right? 360k, k is an element of integers. And then in the third quadrant, I'll say, remember the third quadrant, you have 180 degrees plus theta, so it will be 130 degrees. No, it's gonna be 180 plus theta, which is that, then plus 360 k, and k is an element of integers, right? But all of this, we're gonna do it, I am very sure, I think it's the next videos. Yes, the next videos we're gonna talk more about this, so stay with me.